Suresh. First of all, thanks to Padma and team, right? So they've been doing a phenomenal job. And it's my first time. And hope to be in the future. Before we start, talk about the funny experience of our came to Seattle for the first time. It was end of March. The first day, driving license of the bank to the how nice and they found and I'm feeling more than 60 what is get talking about, right? But the engineer of river can still that then how weird the weather is. Then you get an instant friends. Some do parts of years and on stage the weather was great. And then thinking excellent. Then it's become a part of the specific purpose, right? And fully now genuinely hope we are doing the right. So I lead the data platform for Microsoft Sentinel. Right? What it means is I talk to big teams across the country, trying to figure out how to make AI work for basic stock analysts. Right? And today, I want to talk about one of the most important pieces of that conversation in the and we in Microsoft call it the security data gravity. And I'll walk through why this is a prerequisite for the agentic. Right, you may have heard and across the sessions today, right, this was one of the things that we have been hearing. I wanted to do it. So now let's get going. Okay, let's talk about a landscape shift, right? So this is something that we already know. Right? The market is in the general rush, right, for AI security agents, right? If you look at 70% of security teams are deploying agents in the next 12 months, right? So they're not talking about evaluating, piloting. So they're talking about deploying in the endpoint environment, right? And this is a very remarkable number. It means AI is not just research item. Now it has become part of the enterprise. So that's how market thinking. What that means is we are at a tipping point for AI, and how do we make it work? The next one is for the by 2028, we are expecting 1.3 billion security agents to be there in our portfolio across the world. And if you look at every seam and sword, right, especially if you went to analysis, right, there are few common themes that came. Right, one was the agentic clock. Right, the second one was about autonomous agents. Third one was fast response time. Fourth one was so these were the common themes, right, across the industry and across the security providers. And the promise is actually incredible, right? And interesting part is we are seeing it happen, and it is in. But at the same time, we also see teams who are deploying agents, which is not yielding the positive results. What I mean by that is it's causing more confusion, right? They are getting FPs faster. They are making bad decisions faster, creating a loop that is petty than what it's actually trying to see. And that kind of brings us to the uncomfortable truth. So most of the requirements that we see are perform or maybe fail. And the reason is not what we think it is, right? The problem is not the AI. The problem is the data is running. That is going to be the key factor that is going to determine how good our AI investments and tools are going to be. So, and there are three, the weak link is the data foundation. And there are three specific failure models we can think of there. Right? One is the data. Right? This is what Krishna don't have your defense that you can get out of it is also going to be fragmented, right? And the reasoning as a result is not going to be effective. And the second one is context, right? Uh, Quite underestimated in the AI world, right? Because a poor context leads to a poor AI judgment, right? So when I talk about context, in this, we have no signals about what can do. Like the user, characteristics of the user. Say the C user, the user, when to read the those signals, events. Third one is data. So customers use a variety of security controls and you don't get the entire estate with which you can make more holistic and secure and fast security. Right. So what's the addition to this? Right. So we call as the security data gravity. So let me give you what I mean by security data gravity, and then we'll walk through the various pieces, what it means, right? When it gets into practice. Security data gravity is a tendency to access more data, tools, workloads to replace thereby creating a self-reinforcing platform for defense. So kind of creating a flywheel, right, for your data and your agents and analytics on top of the data. That is kind of borrowed from the world of cloud economics, where you say idea is that your data exists in one place and all the processing analytics gravitate towards the data. So there are three pillars to think of, right? One is the breadth of data, right? This is about you get various signals. You get signals from endpoints, network, application logs, HCR, so many other tools, and right. How can we have all the data in one place, right? So there's no picking and choosing of what data you want. Get all the data in one place, right? So you can add more value to what you want to do from the security. And take context, right? This is what you talk about. Say, if you know relationship history, behavior patterns, more characteristics, right? A simple example, I can see this share and document is this is a typical PT of what you want to do. But how do you have sync from the users, the skills? SharePoint is this document, it's sensitive. It's a sensitive. So you can, by events, maybe 1000x more value to that event than so that's what the context needs to be over together with data with which you can make effective. And the third part is continuity, right? So how can you make it move over time, right? Many systems process the data, but it's talking about many of the attacks is known, right? They be in the environment for multiple months, years, study the environment, how to compromise to get the best, right? And also you cannot establish some of this behavior with a small time base, right? So you can also behavior months later, and create a baseline for what the user behavior is. And here is where it's interesting. And let me show you what an environment actually looks like today. So this is, kind of this fundamental health. I don't think I see lines properly. Right? So this is gotten documents direct now, right? There are 45 single scenarios that enterprise uses. So think of it as in there are multiple vendors, right? There are some vendors, media, some vendors would have email capabilities, vendors would have posture management, right? And is today. And each tool has its own view of what the performance looks like, etc. And you have this analyst in the middle who are trying to correlate all to figure out what's actually happening in the organization. Right? So the time the analyst uses is spent trying to correlate this than taking meaningful actions, what we should be taking. So this is what leads to the delay, right, and the fatigue that we call that. If you get this day and day, it's very much nice. So the fundamental problem is you cannot train on AI agent which has incomplete siloed view of the data and expect it to behave like an expert. Right? This is the agent's output and response, or the reasoning is also going to be fragmented when it comes to what data. So let's talk a little bit more about this context. So let's take a use case, right? And why context is so important, right? So I'm building an analogy between a new software analyst who joined the organization and he's looking at his input to try is a play. Compare it to a 10-year veteran in the industry, right? Who has a perfect recall of everything that happened, what kind of issue that happened, why it happened, how did the attack come in, what happened they do, etc. Right? So there is a day and night difference between the outcome or output of the news levels versus the level. Right? So our agent is one of these two things. Right? So either our agent would behave like a news analyst without context, or the agent can work like a veteran and provide insights rather than just provide alerts that you know. And this is where context comes important. One is forecast. Right? We always right? So sense of device. It's two different things when you see. First, that for than the end user laptop, right? Similarly, user behavior, right? So if a user walked in, right, at 2 a.m. and from a new country, it is a common pattern. It is a see that all this new we are seeing sometimes it's not supposed to happen. Right? Threat intelligence, right? You get these various signals about IP reputation, domain reputation, etc. Right? Those kind of signals are also important. And historical patterns, right? We've seen before. Right? These are kind of table stakes from my point of view, and these have to be automatically available to the system, right? We don't even have to do the manual work, collect the information. Right? And this is what we want to make it happen, right, with the data foundation. Right? And without this context, your AI is going to generate noise and not insights. Right? That's going to be the difference. And the difference in that is going to be a solid data foundation. Okay. So I want to talk about what this high data gravity means. I think of it in terms of pillars, right? One is ability to ingest and processing all data that you have in the system. Are you able to normalize a consistent and a common schema? So tomorrow, if a new kind of data comes, you can use the same playbooks and run meditation to bring them into my detections for every scenario. Exercise some is common. The document enrichment, the IP enrichment, user enrichment, the end of job is kind of you have this million that users can use those solutions. Easy on what is an event of interest, what is align interest that go against. I will purchase no games to something like this. Let me okay. So we talked about the need for data being there for longer period of time, right? And this is so the fundamental thing I want to all of you take away from this is it's not about what AI agent, right, or AI product that we are buying, right? It's all we have to think, okay, do we have the right data foundation on top of which the agent is going to provide. So this is I tried to create a mental model around it to say how we should think of from the agentic security architecture, right? So I'm thinking of it, right? There is the use of data. There is some either data foundation, which is unified, contextualized, isolated, right? And this is what is going to bring the with respect to agents and tools. It's something that we talked about how can I enrich all the data with virtual enrich. Now this world of actually like this is single intent some of these models, heuristic based models, etc. How they take these signals or take this complex and take this signals. Yeah. Prevention, remediation, and this foundation for the autonomous agent. How you can take some of this context and then do this is always this huge so this is an invest in they need to the lead. In first one, function and so the big functions MDU, right? Family, right? So if I can be over pivoting on once, right? So if you talk about the next location, and that also has implications. This is more it's just implication becomes security or maintenance. So so the in this question, or at least agent doing the meeting. Forms the core of how we can operate with agents effectively, carefully and accuracy. So you may take some that reading down and talking more how to what spirit. So let's talk about case, right? So how it a world without agents and a world with agents. So on the I'm talking about scenario before, right? In the way things are going. So with different knowledge. So he's going to look across. So do I see similar activity? I see about the right? Probably yes. So it's going to be dangerous. Right? AI will give you both speed and the accuracy that you're looking for because it's reason with the full context. Right? That is going to be if you miss that we are so now I'm part of Microsoft, so I have to talk about Microsoft Sentinel. Right? So and this is not a product, right? Instead, I want to share insights, right? What we have thought about and how we have built a system to illustrate, what data can be set, from our enterprise. Right? So the first one is petabytes, but more in unification of accessing using one single construct, which is secure. So that is how and there is a language with which we let all our functionalists come and access and play with the computer to analysis and investigate across the entire data set. The second one is so this we have this history of connectors when we data any three resources, right? So we're creating this and recently we did this agent which can build connectors, right? Because they talk about process and I think we spoke about it much. This is the security copilot agents, right? So we are investing heavily in the infrastructure, right, for the data platform as well as in our security agents mounted on the Sentinel data platform, which can reason out this data pattern, right? And grounded here is a key how we are using all the things that we talked about in contextual engine, history, and things with which how we can do things effectively. So to be the gravity well for security. AI agents have information. And in this deliberate architecture choice, if you think about it, it reflects on the principle that regardless of which platform you are in, right, having this data is the first capability that you need to have. AI capabilities, will follow it automatically. The thing that we need to look at is agents, right? How this is not something it is not very so given the feature for to me. Should I not signals to the the points when the longevity that it gives. So quickly, let's recap. So I'm just going to create this, right? So data platform is a prerequisite. AI agents essential constituency using agents or and the data available is slow to AI models. Because the AI data is reserved. It's the problem. Control scale AI judgments. Right? This is what we saw. Don't know what it is. You don't make a better decision on the data. It's just noise. Clean getting noise. Right? Rather than it is useful. That's more optional for you from an organization. And it creates plan, right, which will bring in food. So you can have the platform, right? And you can have the relatively use the platform to do what we are looking happy to do. And that I think I'm confident. Yes. Okay. Fine. All right. Cool. Thank you I'll be outside if you have any, or I'll be inside if you have any questions for me. Definitely do reach out. So please feel free to talk. Thanks. Perfect. Yeah. One question. All right.
5 layer from 01, 02, 03, 405. And first layer is my question is people put a lot of data to to go to your site and how would you filter it? Because a lot of social media
Yeah.
and it helps to know which layer you can filter because unified data to use things like you can find all the data using those they filter in the 01 or you take it as really
Definitely. Thank you so much. That's a good question to say. Yeah, mostly like filtering through to say what is of importance, right? And it's the situation. What is importance? It's important. Maybe of importance in the field. I have from CSRB. These categories data observability data, where the data is right, where in the complex, because the data is being used to get visualization, right? So any data data, but the same thing consistently system based. So this is data system we are able to clear the data. Okay, and we put all the data on the the cheapest tier, which remains in the computer. Some house kind of thing. Very interesting data, right? It would be that interesting global contextualization or physical contextualization because along the years of very awesome Michael. We will be able to say if you look at the same store, you need to call it as stuff. So, processing loading. You know, you bring it's like one patient here. Yes, the same. Thank you, sir. A round of applause for Suresh. Next, we have Kannan Dhanasekaran, who is a partner and engineering manager at Microsoft. Uh, he'll go a little more deeper into Sentinel and talking about Sentinel graph as context graph for agentic security.
Okay, can you present and I will connect it to mine?
This session has been that I can see and the room is Suresh will also be outside once this session is done. Okay, thank you.
Yeah, you can go ahead. Okay.
Right. I'm actually a visual person. I always like to for the digital world to overlay the physical world and life. People do it here, but I like to look at it this way. What is life? Does anyone want and tough, deep question, not tough, but it's a deep question. Think about life. And then there are three aspects to it. Personal life. How do you define life? It's all about need. Three aspects. Personal life is all about the I think about the life. It's all about the connections that I have with my coworkers. And when I think about my social life, it's all about the networks that I have. Right? And the common theme in all of these things is the connection. Without connection, the next applies when we think about
You may be wondering why I'm talking about lines on that. I'm trying to come to when we think about security, connections, right? Like in the stations today. So connecting the dots. We need to be able to connect the dots. And similar to life, it's not just one facet when we think about security. Very different domains. Like you can see, we have identities, we have workloads, we have like agents, applications, and being able to connect all of these things together is critical for security. Without that, security is meaningless how we think about it. And we at Microsoft, we have built what we call the Sentinel graph that connects the dots together. So before I dive into Sentinel graph, I want to talk a little bit where we are today. There's nothing novel in it. What I want us to think about is physical like back setting. Okay, you have an event for that. There is an event where some person was walking into a hallway. There is another event that's saying that all of these are individual events, but all these events result in path getting we never saw. Typically today, these attacks are linear. Keep targeting them, and once they are slow, they accelerate and jump. And that is the kind of attacks that we have today. But the kinds of attacks that we have seen in the world, right? These attacks are very sophisticated. They are multi-stage. What do we mean by multi-stage? The things that you see in the traditional world, the moment you explore and accelerate, today people don't do that. Some very small subsequent. But what they do now is they find and explore. They learn the experiments from within. So they are plotting the next step that they want to take, and they keep moving. Take this within the system. And it's not multi-stage, it's also multi-entity. Like I say, come to the some user still going in control. I keep traversing through the system and creating a multi. That is the kind of that we see. And through all this, what we have done, right? One of the things that we say is once the attacker gets in, we are mixing the system for 10 state. And we have seen cases where attackers have been for more than 6 months. This is actually happening, and the way attacks are very I have done something, I want to see as much as I can and keep doing that. While they do that, in fact, plotting the next once they get into the system, they stay quiet for a little bit so they don't give clues that they are in your environment. They're staying there, learning more from within the environment, right? Sometimes with defenders ourselves, we don't, but the attackers are very sophisticated that they are very motivated approach. Right? And what we have done really well is we built a lot of these correlations and detections and all of that. The side effect of our defenders no different no different than we drowning in notifications. I don't know how many of you see, but team conversations slowly period of time you start keeping track of all these things, right? Like the exact same problem that we have with these alerts, right? Like they just don't scale. So where we are today, we have actually done a lot of correlations, detect. We have done all this. What it has resulted in we have more alerts now and very less clarity of how we want to mitigate the problem. trying few different things, but we are always advantage. Right? Like that is the current state of things. The difference think in graphs. Will it make things any different or better? That is what I wanted us to think about. And the things that I want us to be mindful of is it's not going to happen over in a vacuum. Suresh was saying, this happened all these years, all of this counts the richness of the raw signals, your graph is not right. Over time, from the raw signals, we went and created these other correlations, findings, whatever techniques we had, we went and created all these and from alerts, we created called as an incident, right? Like I can group a bunch of alerts that are related and I created an incident. Now, what the graph lets us do is it's going to connect all the context for which we had before. The specific disparate alerts or incidents that we're looking at, we are actually bringing all of these together in what we call as connected context. Right? So what happened before us is very critical for graph-based intelligence. Okay. Now we are able to provide contextual intelligence on top of all the data we have in the system. So one of the important things is why graph, I will say this very prerequisite for every detection. That is very good at doing, and it does it really well. It continue using. But what the graph provides is it gives you a lot more information that it's not like you cannot do it. It takes time for us to get that view. What it's like it tells you the actors who's causing this. Now, the moment you find this actor, you can actually go and see like what this actor is doing. To analyze and say that this one actor is doing many things, not just one. Who the person is doing. And it tells you how the attack is moving. One of the things that I like is detecting movies kind of a thing. And we can see that system. Okay, this is how the attack is travels for human status to understand what actually is, right? The important thing that it provides is it tells you what kind of techniques are being used. Right? You can see that it's insert was user control, exploited. So you can see what kind of techniques are being used for that particular. The other cool thing that the graph is, it is not only a attack. You know that something happened already. But what you do not know is what is the actual impact of this problem, right? I I know that process of now at risk, right? But that alone Kannan adds to that compromise can do other things. Right? The mass radius of that. The graph can do, can do something more, which I will talk about. I want to introduce you to sectional graph. We're having this graph for a year. Keep the discussion on sectional graph for people who want more details, and we're happy to go into technical depth offline. But the few key things that we want people to when we talk about central graph, I don't want you to think of one giant big graph. Think of this as the world map. Okay, when you think about security within the context of an organization, you want to view everything. Things, right? We have built a layered system. We end layer. What we call as the base layer. In any enterprise organization, When I say think of these as cloud resources, that's leakage, these are all different. You can actually model these and create a graph over them. Create an influence graph, graphs. You can actually see what are the can reach into whom. And you have base graphs. The base graph of the foundation layer. Right? Without base graphs, nothing else works. And what's more cool is not that we can only create the domains. In your enterprise, you can model a base graph for your enterprise. You can create a custom. That is one thing. The second layer is what we call as the security layer. Let's say that I'm interested in phishing campaigns. I want to create a phishing kill chain. I can create it on top of additional data points. I'm interested in blocking laterals, right? So you can create a graph for lateral. You can create any kind of graph. I want to create instance. That is the security graph is what we call. And the way to think about that, right? Same with my I have given my identity now. For a period of time, I'm lighting up that my map is fuller and fuller. And the beauty of this thing is the more that you light up, the more connected and more powerful your graph becomes. So that's right. Now we must stop there. There's another thing you think about, which is what we call as enrichments, right? The fact that I have all these different cities lit up on all flat. And I'm going to Seattle State. I'm interested in points of investor. Enrichments that have the fact that I have all these documents, these alone is not enough. These are which devices have the CVs, right? All of that will remain layered on top of the security graph as an image. So that's the searching on. Now, any ISV customers, they can. Now, when we think about not a problem, you probably need to model the graph. Okay, so then why not something great, right? PhD in data science. But you can 20 minutes. And here actually would get a mobile and have this game today. You can actually get a blue white, but we call this as white graphic, white code. And this is I want to do a central graph lateral movement in my amortization. I started with one statement. In 30 minutes, I environment and I see that in the knowledge. 30 minutes. And I'm like PhD can now do this. And also be honest, I'm not saying that grab the 30 minutes, I will deploy to product lateral. But it's for people to model these things fast. That's what makes it super powerful. Okay. The important thing I want you to understand is because we are built on top of this data graph talking about, the data is there, and even the graph created on top. So I can go back in time to look at the state of my environment at any point in time. So you think of this as a time travel movie, right? Oh, I now see this new capability. I want to back. You can do it. So it's super powerful that way. Okay, so now we have the graph. And we talk about agents all the time. Without agents, there's no security of future, right? And most of you already, but for people who do not know, autonomous talk is happening now. It is not sometime future. All vendors have autonomous talks already. Um, Autonomous talk cannot be successful without a graph. It is a graph problem. That is how we stuff. And the graph is heavily integrated with all the autonomous talk agents. You are in the process of building autonomous agent and you do not have a graph, please do think about it. Okay. I do not know how many hallucinate, but I dream a lot. Agents hallucinate. When agents hallucinate, it's pretty different. Okay. Examples. Like one block that I keep. As a result of that, it actually prevented access to the entire subnet, right? So all the operations are on this because right? If you do not have this graph-based context, and you're not grounded in this, the response of the agent is not concise, and there is no way to explain why the agent did what it did. It do all these kinds of destructive actions. Okay. So now with the capability of graphs, how does it help the defenders? The triaging is faster because the agent is doing the triaging, not because the infer get the context from the graph and act much faster. So these things inside. The thing is, the agents now have full entity context. What this entity did, what are the alerts, it can do all of that. So it now can look blast radius. So previously when we did alerts, we initially had flat list of alerts, and then we said that hey, let's prioritize the alerts. Critical, but then that also became the spot where we start. Now, with the concept of this blast radius, right? Like you can really understand and weight, and you can tell things because they impact your organization. So it's super helpful in that way. So now the defenders have the benefit of this tool at their disposal. Okay. The other thing that I wanted to talk about is we've been doing the central graph. So what are the learnings? One of the things that is very important is the fact that I have built this world map. If I dump this world map into the great things, that's not going to happen. Okay. Garbage in, garbage out. Give the whole thing to do the same we have today, right? So the core of what you're providing as context is critical. If you're interested in documenting an incident, the context needs to be scoped to that incident. So the second thing that we have found is in incident investigation case now, so I cannot build this whole graph all the time because to the scale we're talking about, and today we have like 100 million plus nodes and edges customer screen. Then Microsoft, we're looking at a multi-billion scale graph. Being able to rebuild is not possible. So we actually do this in an incremental way. So we can keep building the graph at a time without compromising on the freshness of the graph. The thing is the most okay. The agent did something without it is very hard for anyone to trust it or defend it. In enterprise context, if you do not have defensibility, nothing matters. Okay? And I thought the hallway today saying like 94% of the time, maybe that is okay, but for the other 6% of the time, I don't know why. That's not okay. and need to know what it did, what it did. How do you do that? The graph is the evidence for that. Right? The context is actually the context that is very valuable. Without that, there is you cannot do enterprise scale agentic security. One more thing, like I said, all good, but what if you can actually detect the step that the attacker is going to take, right? And with the graph, now this is possible through what we call as attack path. So now this changes the game completely from being a defense, you're actually going on a proactive defense or offense, right? Team reach and make your posture better. So continuous thing better. So from being a reactive system, now you're a proactive defensive system. Okay. So the key takeaway, there's one thing that you want to say. Agents are smart, only as good as the context is. Okay. So if you do not have that is supporting the agent, make sure that you have a graph that can actually connect the dots and bring all the intelligence that the agents require. Okay. So that's all for your time. If you have any questions, I'll be happy to answer. Okay. Thank you.
Thank you, Kannan. I think Kannan will be outside if you have any more questions for him or any questions for him. We can. Okay, looks like we can take questions. So any questions for Kannan?